Hi, in this discussion, which is divided into two parts, we're going to talk about 2D graphics under iOS. So, drawing 2D graphics is really pretty simple. We draw 2D graphics directly onto a UI view object. So we instantiate a UI view, and then within that UI view, we use a method called drawRect, which is where we use primitive drawing functions and other functions found in the Core Graphics framework. We don't have to import the Core Graphics framework. Core Graphics is imported by default in a new iOS application. So when we start an iOS application, we'll see that we have already got, if we look in our frameworks, we'll see that we already have the foundation frameworks, the foundation framework, the UIKit framework, which gives us the controls, and also the Core Graphics framework. For any additional functionality that we want, we can import the actual Quartz Core framework. Quartz 2D is the framework containing all of our graphics, our 2D graphics functionality. But Core Graphics gives us enough to start drawing 2D graphics directly onto a UI view. So the coordinate system is a little bit weird. Core Graphics uses an XY kind of Cartesian coordinate system, but the y-axis in Core Graphics coordinates, or in Quartz 2D coordinates, is inverted. The x values still increase from left to right, but the y values increase from the top toward the bottom. So we have a little picture here that shows x coordinates increasing to the right and y coordinates increasing to or toward the bottom. Now 0, 0 in this picture is assuming that this little view that we have here is showing its own bounds coordinates, and we'll talk about that in the next series of slides. And then WH stands for the width and height of this little view that we're showing here. So let's talk about frames and bounds. The frame of a view, or a control, or anything that we place as a subview of a view, is a rectangular area defined by the XY coordinate of the top left point in the context of the view's container view, and then the view's width and height. So we have left, top, width, and height. And this is the frame. The bounds of a UI view is the rectangular area of the view within its own context. So if you think about that for a moment, the top left corner of the bounds of a view will always be 0, 0, whereas the top left corner of the frame of the view will be wherever that point is within its parent or its containing view's coordinate system. So what's the difference? Well, we use frame coordinates when we want to specify the placement and the size of a subview within a view controller's main view, let's say, or within some other containing view. And we use bounds coordinates to draw points, lines, paths within a view. So the bounds coordinates have to do with that own view's context. The frame coordinates have to do with the view's context within some larger view in which it is embedded. So now let's dig into this a little bit deeper. Suppose we have here view 1, and this is the entire size of the screen, let's say. View 1's frame is going to be a frame made by a primitive that we are using CGRect make, which actually makes a C struct. So all of our Core Graphics framework stuff, all of this primitive stuff is embedded in C structs and floats and C functions which do this stuff. And we're going to talk about some of these primitives after we talk about frames and bounds. But for just now, assume that we have a function called CGRect make that takes x, y, width, and height. So this view's frame is made by declaring a CGRect called frame and then calling CGRect make, the function CGRect make, with 0, 0 and width and height. We're assuming that this is view 1, the whole screen. Now, the next step, let's say we create a new view. So this is called view 2, And View2's frame is a CGRect, and we make it by using CGRect make 50, 30, 100, 80. 50, 30 is the top left corner of View2's frame, and 150, 110 is the bottom left corner that is gotten by 30 plus 80, that's 110, and 50 plus 100, 150. But when we specify the frame, we specify the top left corner, this point, and then the width, 100, and the height, 80. So the frame of View2 is 50, 30, 100, 80. And again, it's the frame, in the coordinate system of View1. So the frame of View2 is always declared within the coordinate system of View1. Now, let's dig a little bit deeper here. The frame has properties. Just as View2 has a frame property, the frame has properties itself. View2.frame.origin_x is 50. View2.frame.origin_y is 30. View2.frame.size.width is 100. And View2.frame.size.height is 80, as we can see right here. So the frame never specifies the actual point 150, 100, but it specifies 50, 30, and then the width and the height. Now, digging a little bit deeper, let's talk about View2's bounds. View2.bounds.origin_x is 0. View2.bounds.origin_y is 0, but the width and the height of the bounds is the same as the width and the height of the frame. So now again, we specify where View2 is and how big it is by using its frame. We specify drawing coordinates within View2. If View2 is going to be used to draw, we specify those coordinates by using View2's bounds. I hope that's clear. So I think it should be at this point. Okay, so now there are some defines within Core Graphics that we need to talk about. There are more than this, but the three most important defines to get started with in Core Graphics are CGFloat, CGPoint, and CGRect. CGFloat is just a type def float. It's used for a lot of things. We use floating point values, CG floating point values, for color values and point X and Y coordinates, and a lot of different things. Any place you would use a float within the context of Core Graphics, we want to use a CG float. You can get away with just using a float, but let's keep Core Graphics with that CG preface. A CG point is really just a C struct that contains two CG floats named X and Y. We can create a new CG point by using CG point make with CG float X, CG float Y. And this function, this is a C function, will return a new CG point structure. CGRect is also a C struct, and instead of containing two CG points, it contains four CG floats, X, Y, W, and H, or width and height. And it can be created by using the function CGRectMake with the X, Y coordinate of the left top corner, and then the width and the height. So that's part one of this discussion. Thank you very much.